All right, I think let's get started. So, hi again, everyone. Thanks so much for joining for today's webinar on reduced oxygen packaging. So this webinar is part of a three-part webinar series hosted by the Farm to School leadership team here in Minnesota. And this webinar series is focused on farm to school and food safety. So over the course of these three webinars, we're going to be talking about food safety rules, regulations, and considerations that come into play when buying and preparing local food in schools. And so the three topics, today's topic of reduced oxygen packaging, as well as local animal proteins and wild foods and more, are topics that were chosen based on common questions that members of the Farm to School leadership team have been receiving from a lot of school and early care buyers. So our hope for these webinars is that they provide food service professionals with some clarity on relevant food safety topics that come into play with farm to school items and practices, and ultimately help all of you feel more confident in buying and serving local foods in schools and early care centers. So we can do some quick introductions here. My name is Kate Siebold. I'm the Farm to Institution Coordinator at the Minnesota Department of Agriculture, and I am just our kind of host and facilitator for the day, but we have three fantastic experts that you're going to be hearing from. We have Amy Johnston, who is a regional extension educator on food systems and food safety at the University of Minnesota Extension. And then we're also joined today by Amy Hagg and Rob Richardson with Hutchinson, Litchfield, and Dassel-Cokato Public School Districts. So you will be hearing from each of those folks over the next hour. Our plan for today is you'll hear about what is reduced oxygen packaging, also known as ROP. I didn't know this acronym until we started planning these webinar series, so maybe it's new to you as well. But we'll be talking about what reduced oxygen packaging is. We're going to talk through food safety considers in reduced oxygen packaging. We'll discuss Minnesota food code requirements, HACCP plans for reduced oxygen packaging, and then highlight some resources. And finally, we'll end with questions. And as you have questions throughout this webinar, you can enter them into the Q&A, and we will make sure to get to those over the course of the webinar. Our learning objectives for today are to help you understand what reduced oxygen packaging methods can be used in a food service operation, how to apply this information to planning meetings and conversations in your department or school district, and help you know what resources are available and who to contact for assistance in planning for reduced oxygen packaging in your food service operation. So before we jump into things, we thought it would be fun to do a quick poll and just kind of see who is in the room with us today. So I'm going to start a poll that will ask you to share how familiar you are with reduced oxygen packaging. So let's get that poll started. All right, you should be able to answer. All right, see some results coming in. I'm relieved to see I'm not the only one that wasn't familiar with the ROP acronym before. This is good. All right, is everyone else able to see the results, or is this just me so far? Okay, you can. All right, great. Well, that was fun. It's helpful to see we've got a couple experts here. We've got some people that reduced oxygen packaging rings a bell, but they've never used it. And we've got some people that are really here to learn all things there are to know about reduced oxygen packaging. All right. Great. Well, with that, I'm going to turn it over to you, Amy.
Great. Thanks, Kate. So I'm really happy that we have such a mix of individuals here today. And So let's just start with some basics and some definitions before we dive in. So reduced oxygen packaging is the process of placing food into a package, removing all or the majority of the oxygen from inside that package. So it's less than the amount of oxygen naturally found in our environment or atmosphere, and then hermetically sealing the package so it's airtight. Um, just for context, so our atmosphere, our environment has about 21% oxygen. So any type of package that has less than 21% oxygen is considered reduced oxygen packaging. And there's a few different reduced oxygen packaging types that we'll discuss here shortly. But why would someone want to use reduced oxygen packaging? And a common reason is to keep food fresher for a longer period of time. Reduced oxygen packaging can extend the quality and shelf life of the food. So before we move on, I just want to make a quick note that instead of saying reduced oxygen packaging every time, I will probably just say ROP. Okay, so there's three types of ROP that I'm going to go into detail about, and then two that I'll just mention so you're familiar with the terms. The first type of ROP is vacuum packaging, probably the most commonly method that people think of. So when using the vacuum packaging method, the food is placed in a non-permeable bag that's designed for ROP and is able to be heat sealed. That bag is then put into a chamber in which the air is removed or sucked from the inside of the package. And then that package is hermetically sealed using a heat bar to keep it airtight. So the images of the equipment on the screen are just to provide you with an idea of some different options available. This top image is an example of a countertop single vacuum chamber. There's also floor-based models, and a single chamber model is typically used for a lower to medium production volume. And the package is placed into that chamber. The edge of the bag is placed on that brown colored bar. And when the lid is closed and the machine is run, it sucks out the air, and then that seal happens across that bar. The bottom image is an example of a double or a dual vacuum chamber. And this type of model is used for medium production. So you can set up multiple packages at one time. The lid will either automatically or manually move from side to side of the machine. And then there are even much larger models out there as well. And then this last image is just an example of how the packaged foods may look afterwards. So you can see the packaging is tight against the food because the air is removed, and it's creating this anaerobic environment. And later in the webinar, we will discuss the potential benefits of ROP, and we'll get into some more details about what foods can be safely vacuum sealed. The second type of ROP we'll discuss is the cook-chill process. The cook-chill process starts with thoroughly cooking food to its appropriate minimum internal temperature. The food is packaged while it's still hot. So this process, the cook-chill process, is really good for foods like sauces and soups, stews, gravies, anything that's thick and it's going to produce a lot of steam while hot. Appropriate packaging for the cook-chill method requires impermeable bags or bags that don't let in air or moisture to move past the membrane once it's sealed. And that can also withstand really high temperatures, sometimes up to 212 degrees Fahrenheit. The package must also be able to be heat sealed. So when you're filling the bags, the cooked food must be held at a temperature of 135 degrees Fahrenheit or higher while it's being filled. And there's two reasons for this. First, that temperature is right at the top of the danger zone. So it's right outside the temperature danger zone. And the second is that when it's being kept hot, it's going to continue to let off steam, especially once it's poured into the bag. And that steam will also help displace any air from the inside of the bag. And then that package is immediately sealed using a heat bar and then rapidly chilled. And then the last type of ROP that we'll talk about in detail is sous vide. So sous vide is originally a French food preparation technique, and the process starts with raw food being placed in, again, appropriate packaging, the air removed and then hermetically sealed, so that airtight seal. And then that packaging must be non-permeable, be able to withstand high temperatures because it will be cooked in that package. And it's cooked or partially cooked in a hot water bath or a steam chamber. The steam is controlled at a specific temperature for that food for a set period of time. The sous vide process can take anywhere between 1 to 7 hours, depending on the food item and the cut of that food. This method is commonly used for proteins like meats and poultry because it allows for even cooking throughout the entire cut without any overcooking or causing dryness. Once the sous vide cooking is finished, that food is then either immediately served or rapidly chilled and used at a later times. If it's going to be served immediately, it's usually finished then on a hot cooking surface like a charbroiler or a grill to get that nice color and sear on the outside. So there are specific requirements for how long foods prepared with this method can be kept in the packaging once cooled, and we will get to that later once we discuss the Minnesota Food Code. So these images are, again, just examples to provide you a visual of what the equipment could look like. This bottom image is a really simple setup. It's a Cambro type container with a lid and a water circulator, and that water circulator generates the heat and keeps that water moving. And then the top image is a countertop system. It's a sous vide immersion thermal circulator cooker. So it's a all-in-one kind of device that's programmable. And there's also much larger units that can handle large production volumes, and some that even then have a cooling mechanism built into them as well. So I'll briefly mention the other two types of ROP, as you might see it on product descriptions, as these terms are sometimes used when you're purchasing foods from food suppliers. And these are modified atmosphere packaging or MAP. And this is done by removing or reducing the oxygen by adding other gases like nitrogen or carbon dioxide. The packaging tends to be permeable, which can lead to changes of the oxygen level over time. So sometimes lettuces in bags are packaged with MAP. And then the other one is controlled atmosphere packaging, and it's similar to MAP, except this packaging will have what's called an oxygen scavenging product, so something that's going to capture any oxygen that passes into the packaging. So to use ROP methods in your food service operation, there is an investment in special equipment. And again, I'm not providing you with any recommendation on a specific brand or model, but making you aware of the equipment that you'll need to consider. So vacuum packaging requires the least amount of specialized equipment. There's the appropriate bags or packaging, and then the vacuum chamber and sealer itself. The cook chill method may require some investment in additional cooking equipment depending on your operation. Something like large kettles or tilt skillets, maybe filling pumps and funnels to make filling of the bags with the hot contents easier and safer. The appropriate packaging that can withstand the high food temperatures and the heat sealing. You might need a heat bar. And then lastly, some way to rapidly cool that food. Maybe it's a tumble chiller or a blast freezer, because temperature control is such a essential part in food safety for these foods. And then sous vide requires the appropriate bags or packaging, the vacuum changer, and then any cooking equipment. Like I mentioned, there's some fancy units out there that can do all in one, the cooking and the chilling. So just a reminder that any equipment that you do purchase and use in your food service operation must meet the equipment standards as outlined in the Minnesota Food Code. So just look for these types of symbols and discuss with your health inspector before purchasing equipment to make sure it is approved. So these symbols mean that the equipment has been met by the American National Standards Institute, or ANSI, accredited certification program for food service equipment. So these standards mean that if the equipment is constructed with materials that can be cleaned and sanitized, they're durable, and they retain their integrity under normal use, so it will help minimize the risk of any kind of foodborne illness. So I will turn it over to Chef Rob if he wants to just kind of talk a little bit about the equipment they purchased.
Just as far as how the equipment works, it's came in very handy for our farm to school program in the summer times, especially for our raw vegetables, in order to get those sealed up and frozen to be utilized as far as we possibly can into the school season. We have used it for certain cherry tomatoes. There's different settings you can use on this kind of a unit where it'll take the air out and not squish the actual product. It'll do what's called a soft seal. It'll also do a hard seal where it'll take out the majority of it. So we've actually done meatballs that we've made as well from raw, and we were able to freeze those and vacuum seal those totally flat where we were able to get all the air out and then utilize those at a different time. Again, from the farm to school program of the beef provider that we utilize. It's there's many different options on this one. And I believe I want to say it's 21 settings as far as different items and ways to use it. You can also use it for jars if you want to get to that extent. You can use it for like the plastic Cambro style. Storage containers can be utilized in there if you get the different kind of combinations of things to utilize with those. It's coming very, very production. Well, I don't even want to call it production wise friendly as far as lettuce as well. If we want to chop up a whole case ahead of time and then go ahead and seal some of the lettuce. We were told at that point in time that it does last 2 to almost 3 weeks in our cooler at that point before that goes bad. So it extends the shelf lifetime tremendously on a lot of different products. And it's nice to utilize it in the terms of having the fresh product get into the school year, into the winter months and beyond as far as we can have it go.
Great, thanks, Chef. Yeah, and you can see that, so they have a floor model, but it really doesn't take up too much space. And it's on casters, so able to move it around where needed. So again, just a visual to show that there are lots of different styles of these vacuum sealing chambers. And we can turn it over to Kate.
Yeah. Yeah, so just as you're thinking about reduced oxygen packaging and considering some equipment that you may want to invest in, wanted to share a couple grant opportunities. So the first is the Minnesota Department of Agriculture's Farm to School and Early Care Grant Program. This grant program provides funding for school districts and early care centers to purchase Minnesota grown and raised foods. But when applying for a food grant, you can also apply for additional funding to purchase equipment that will increase your capacity for buying, preparing, and serving more local foods. And so that equipment grant could be a way to invest in some of this equipment that's needed for reduced oxygen packaging. This is an annual grant, and it typically opens up in August each year. So just keep an eye out for that grant opportunity. And we can also put the link for the grant in the chat. A couple other opportunities to consider. There is a competitive national school lunch program equipment grant that in Minnesota is administered by the Minnesota Department of Agriculture. It was last opened up last summer. And so I'm not sure the exact timing, but that's something else to keep your eye on. That also funds equipment for kitchens. And then finally, I would encourage you to check in with your local statewide health improvement partnership office or staff members. The statewide health improvement partnership, also known as SHIP, their funding can support farm to school equipment. And so it'd be worth checking in with your regional staff on any SHIP funds that may be available to support equipment purchases for this.
Great, thanks, Kate. Okay, so Chef already kind of alluded to a few of these, which is great, setting the stage. But what are some of the benefits of, or potential benefits of using reduced oxygen packaging in your food service operation? So first is the opportunity for increased purchasing volume, which could lead to some competitive pricing between or from the farmer or grower that you're purchasing from. And as Chef said, you know, ROP extends the shelf life of your foods, so you can purchase more product than you maybe typically would, because you're able to store it for longer. And more dollars spent on local foods is better for our farmers, growers, and our communities. While ROP methods may require some additional time up front, the use of these methods can lead to production efficiencies. You know, for example, like Chef gave the example of cutting up the multiple heads of lettuce, doing that on a day where the production schedule is a little slower, vacuum sealing that so it extends that shelf life for those days when it is really busy and you need that product. Another example is if you use the cook chill method, that could allow for advanced production of those foods that sometimes take a long time to prepare, like certain soups or sauces. Again, those can be produced on slower production days, or maybe you have a prep cook on staff just 2 or 3 days a week. So these kind of tasks could be put onto that person's work duties. Reduced oxygen packaged foods also tend to take up less physical space than foods that are stored in Cambro types containers or cases. The vacuum packaged foods specifically can be really easily stacked on each other in the freezer, which again contributes to the ability to purchase some larger quantities. There's the potential for less waste, either due to spoiling of foods before they're used, or becoming freezer burnt, or the quality, being really negative impacted from freezing in other types of containers, because other types of bags or containers might allow air or moisture to pass through. So packaging this way will help reduce that potential waste. And then lastly, just a high quality and consistent final product. Again, Cook Chill offers an opportunity for consistency because you can prepare really large volumes of the same food, package and store it, and be able to use it throughout the school year. And then sous vide is a way to ensure that proteins are always really tender and moist, which could lead to less plate waste from the students. And now I will turn it back over to Chef and Amy if they want to talk about some of the benefits that the Hutchinson district was looking for.
Yeah, Amy, we were like synced up without seeing that slide of yours or really realizing it. We had kind of one of those things in each of your categories. I'm the farm to school coordinator, which means I handle a lot of the purchasing during like peak production season in Minnesota, which is obviously not peak student time in our schools. So the ROP process and machine was kind of something that fit perfectly into our district because we have Rob and his awesome summer team to handle some of the produce that takes a lot of time. So we also happen to have like a few great produce growers around that it's just not as beneficial to their business model if we're only buying things at scale in September and October. So for us, it has really allowed us to have closer and more sustainable partnerships, both for us and the farmers. So those July and August moments of abundance can be captured for our students. So like that first bullet point is like fresh veggies and meats all year round has allowed us to really have diversity across our farm to school program. We also kind of like nerd out and have fun when we can vacuum seal some basil that's like aromatic and lovely. But if you've used it at home and you know that if you freeze basil, it's like brown and slimy immediately. Not the case when it is vacuum sealed. It is bright and aromatic, and Rob can throw it into some of those dishes that we maybe do a quick scratch during the school year, but by adding those like really aromatic, high quality flavor components, the students can really taste and smell the difference when things are cooking in school. We always say like if it smells like home, students are probably more likely to eat it. So just little things like the basil and the lettuce are like, woo, we can get really excited about those high quality additions. Sauces, soups, and gravies that can be made during slow periods rather than like those easy production days. We have like the month of August where our farm to school or our summer feeding program kind of wanes, but local veggies are at like peak during August. So we buy a lot of tomatoes and peppers and all those things that we can package and handle in August to use during the school year. The other thing is that we don't want to bring in one farm just to like beef up our back to school, like 2 weeks of procurement. So using the ROP strategically, the vacuum sealer can be used strategically during those first, like the last 2 weeks of August to help us get enough of all of those awesome things to serve our students. So we don't have to bring on more farmers just to like help us initially hit that peak demand. Improved shelf life, of course, we've touched on that. And then long-term financial savings, we do think that by reducing waste on our end and then making things that taste better or look better for the students is gonna help us cut waste. The other thing is that the model that we have can do more and more and more that we don't really need it to do right now. But in terms of like the sous vide option, there's like a tenderizer and a marinating feature on the model that we have that can tenderize and marinate rather than like an overnight. It can do it in like 45 seconds and really pull all of that stuff to flavor the meat internally. So we haven't totally explored all of the features yet, but I think it's going to be a really good tool for our farm to school program.
Awesome. Thanks, Amy. Anything that you want to add, Chef, or did Amy hit everything on the head?
I think Amy hit it all on the head there pretty well.
Awesome. Well, great. Well, before we shift gears and talk about the food safety involved in ROP, are there any questions in the chat that should get answered so nobody's hung up before we move on?
We don't have any questions that have been submitted so far. If anyone does have a burning question right now and you want to throw it in the Q&A section at the bottom of the screen, please feel free and we can answer those. But so far, I'm not seeing any.
Okay, we'll jump in then to food safety. Okay, so raw foods, they just, they naturally contain microorganisms, and some of those can be harmful to people when eaten. And these can be bacteria, spores, molds, yeasts, viruses. And bacteria and viruses can also contaminate food when unsafe food handling practices are used. So when handling and preparing foods, you all know a food safety goal is to prevent the microorganisms from growing and kill them during production. So to prevent or limit the growth of these microorganisms, there are 6 factors that can be controlled in the food service operation. And I want to just spend a little bit of time reviewing them because they, a nice refresher will help make some of the food code requirements make a little bit more sense. So again, I'm sure as food service professionals, you are familiar with these factors, but this review will be good. Just bear with me. So the 6 factors that can control or prevent bacteria growth are controlling the food source, the acidity or the pH of the food, water or moisture, oxygen, temperature, and time. So when we get to the part of this webinar when we're discussing the types of foods that can be vacuum packaged and how long ROP foods can be stored, this information will really help you understand why there are these different requirements. So microorganisms, again, such as bacteria, molds, yeasts, and fungi, they all need a food source in order to grow and multiply. Just like we need an energy source or fuel, so do these microorganisms. Proteins and carbohydrates are good food sources for these microorganisms because they contain carbon, nitrogen, and other nutrients that pathogens need for growth. The acidity of a food or the environment of that food also impacts if a microorganism can survive or grow. So pH is the measurement of the acidity of a food. pH just stands for potential of hydrogen. And the pH or the acidity is determined by the number of active hydrogen ions in the food, that potential of hydrogen. So the pH scale ranges from 0 to 14, with 0 being the most acidic or a low pH. 7 is neutral, so think of distilled water, and 14 is the least acidic. It's got the highest pH. You may have heard terms like basic or alkaline. Foods with a pH of 4.6 or less have the ability to minimize the risk of growth of harmful microorganisms because the acidity can change the physical form or structure of that microorganism and prevent it from growing. So foods with a pH of 4.6 or less are called acidic. Microorganisms also need moisture or water to grow and survive. How easily microorganisms can get the water for growth is impacted by the water activity of the food. Water activity is the ability of free water molecules to bind with other molecules. Other molecules could be the sugars or proteins in a food, but they could also be microorganisms like bacteria. The water activity scale goes from 0 to 1. Foods that have a water activity closer to 1, they are more moist and can promote the growth of microorganisms because the water molecules are easier to access. That water isn't bound by anything else. And then foods with a water activity of 0.91 or below, and that are held in refrigeration, have been shown to minimize the ability of bacteria to have access to that water for growth. So you can remember that 0.91, that'll come up later. And then oxygen impacts the growth of microorganisms, including bacteria. There are microorganisms that need oxygen to grow and survive, and then there's others that can survive without oxygen. So during the ROP process, all or the majority of oxygen is removed from the inside of that package, and that creates an anaerobic environment. So an anaerobic environment is an environment with little or no oxygen. So inside this jar is an anaerobic environment. There might be some other gases present like nitrogen, but the oxygen has been removed. And then an aerobic environment is an environment where oxygen is present. So inside the second jar is an aerobic environment. And again, there could be other gases present. So food that's stored in an aerobic environment, it's going to be and if the food does have any bacteria on it or contaminated, that bacteria is going to be able to thrive. So because ROP is creating an anaerobic environment, we do need to be concerned about any microorganisms that can grow in that anaerobic environment. And we'll touch on those in a minute. Temperature plays a critical role in microorganism growth. Cooking foods to the appropriate minimum internal temperature kills microorganisms and in some cases may inactivate any toxins produced by a bacteria. However, we know once cooked or heated, safe food handling practices are needed to prevent any new contamination. Hold foods at 135 degrees Fahrenheit or above to reduce the ability of any remaining pathogens microorganisms to grow, and then cooling hot foods as quickly as possible to 41 degrees Fahrenheit or below. When preparing cold foods, pre-chill ingredients and then quickly cool the final food product after preparing to keep it at that 41 degrees or below. And all of these are just strategies to keep food outside of that temperature danger zone, which I'm sure you're familiar with, which is the temperature between 41 and 135 degrees Fahrenheit, which is ideal for that pathogen or that microorganism growth. And then lastly is time. If a food is contaminated with a harmful microorganism and as many of the other 5 factors are not controlled, if given enough time, that microorganism can grow to very large numbers and make a lot of people sick. So controlling as many of these 6 factors as possible is important for keeping food safe. So there's two microorganisms that require additional attention and procedures to minimize risk when we're discussing reduced oxygen packaging. And these are Clostridium botulinum and Listeria monocytogenes. So you may think of canned foods when you hear Clostridium botulinum, and this is because Clostridium botulinum can survive in that anaerobic environment, so that environment with little or no oxygen. So we need to control for it, not only in canning, but also in reduced oxygen packaged foods. We need to be aware of that, and we need to control as many of the other factors as possible. So Clostridium botulinum spores are naturally present in the soil and the environment, which means they can be present on foods. So in ideal conditions with enough time, these spores can become vegetative cells and then produce a toxin. And it's the toxin that causes the illness, those symptoms you saw on the previous slide. So the ideal conditions for Clostridium botulinum are that anaerobic environment, and then also an environment with a lot of moisture. So a water activity closer to 1, and a low acidity. So a high pH, getting to above that 4.6. And if the spores are not competing for food or moisture with any other microorganisms that might be naturally present and enough time is given, that's when that spore can become the vegetative cell and produce the toxin. So in ROP, we're creating that anaerobic environment, which means we need to use procedures to prevent or minimize the risk of these spores from becoming the vegetative cells. And these procedures include selecting raw foods, because these just naturally are going to have other competing microorganisms on there. Or if you're selecting a prepared food, do ones that are acidic, so that 4.6 or less, have a low water activity, so that 0.91 or below. So examples of these, it could be raw produce, raw meat or poultry, or if you're doing a prepared food in reduced oxygen packaging, you could do a raw fresh salsa, because that's going to have that acidity. And then other procedures, including limiting the amount of time the reduced oxygen packaged food is stored in refrigeration, and these, along with safe food handling practices, minimize the risk of foodborne illness. Next is Listeria monocytogenes. When you hear Listeria monocytogenes, you might think of deli meats or hot dogs, and yes, these foods have been linked to many foodborne illness outbreaks. Similar to Clostridium botulinum, Listeria monocytogenes is naturally present in the environment. It's also a concern in food processing or manufacturing because of just its persistence on equipment. But again, it is naturally present in the environment, so it can be on produce or other foods. And if these foods are then reduced oxygen packaged, the additional procedures are needed to reduce or minimize the risk. So I think of Listeria monocytogenes as a very clever microorganism, because it's what we call facultative anaerobic, which means that it can survive and grow in an environment with oxygen, but then also one without oxygen. So it's very tricky. It can also grow in cold temperatures, and that can also make it challenging to control for. It can survive and grow in temperatures as low as 34 degrees Fahrenheit. So similar to Clostridium botulinum, when reduced oxygen packaging foods, select those raw foods that have the competing organisms, or using the acidic or low moisture prepared foods. And then again, time and temperature control are very important in minimizing the risk of Listeria monocytogenes growth. Okay. We can take another quick pause, just if there's any questions in the Q&A or the chat.
We had one question submitted so far, which was just asking if this recording is going to be available. And yes, it will be. So we are recording it. We will post it on the Farm to School and then website, and we'll email the link out once it is up. So you will have access to go back and listen to pieces or look at slides that you may want to review again. But that so far is the only question we've received.
Great. Excellent. Okay, so before we move into discussing the food code, I don't want any of these microorganisms like Clostridium botulinum or Listeria to scare anybody off from doing reduced oxygen packaging, because, you know, as we discussed, there's so many potential benefits, and these microorganisms can be controlled. The risk from them can be controlled through safe procedures. And, you know, the first step is just having this awareness of these potential risks, and then learning what to do to offset those risks. So as we move through the food code and start to talk about the HACCP plan, that's where we'll get into the specific actions that you can take that minimize these risks. So let's shift gears. Okay, in case you're not aware or you just need a refresher, you can access the Minnesota Food Code at any time by visiting the Reviser website. The link is on the screen. And then in the Minnesota rules search box, down there in the blue box, if you search 4626, that is the chapter for the food code. And it'll pop up, and you can scroll through and read at your pleasure. Another just little bit of setting the stage before we jump into the details. I just want to talk about how the information will be presented. So for the next several minutes, almost all of the slides are going to be laid out in this kind of format. There'll be a snippet from the Minnesota Food Code, which is the rule. The bold text is the rule number and name, and then below it are the details. These are the details, and then after we discuss some of these details, a little notepad will pop up, and that'll include some key points or actions for you to include in your HACCP plan. And I think right now, Kate will be sharing the links to the two specific rules from the food code if you want to pull them up on a different screen or print them for later. And just a little bit more framing before we dive into the food code requirements. So we've mentioned HACCP plans a couple times. So let's just take a quick moment to review what is a HACCP plan and how it's different from a food safety plan. So a food safety plan is something that you all have for your food service operation. It's the primary documents that are all of your prerequisite or your preventative controls in your operation. It's everything that you are doing to keep food safe and prevent foodborne illness on a day-to-day basis. So it's, you know, it's all encompassing. It's covers your entire operation. So it includes things like your day-to-day operation policy and procedure manuals, your SSOPs, food handling procedures, illness reporting, recall plans, training plans. And again, all of these are intended to keep food safe and minimize the risk of foodborne illness. A HACCP plan is different from a food safety plan because a HACCP plan is focusing on a specific process or flow of a food that's not normally covered in your day-to-day operations. So it may pose different or additional food safety risks. So a HACCP plan starts with a hazard analysis, which is where you're looking closely at the food or the types of food products that you're going to be producing. And you're looking to see if there are any new hazards or risks that come up that aren't going to be prevented by everything that's already in your food safety plan. There's 12 steps to developing a HACCP plan, which includes 7 principles, and we will go into more of these later with an example, but just wanting to set the stage for how a food safety plan is different from a HACCP plan. Okay, so now let's finally get into the food code requirements. So Kate shared the links to the 2 rules from the Minnesota Food Code that we're going to review as they impact reduced oxygen packaging. First is 4626.0415, and that is specialized processing variance requirements. And then the second is 46260420. I think I said that right. Reduced oxygen packaging without a variance. So it's important that you have a clear understanding of both of these because it'll guide you in conversations with your health inspector, planning and developing a HACCP plan if you choose to use ROP in your food service operation. Okay, so the first rule, 4626.0415, states that a variance is needed to use reduced oxygen packaging for time and temperature control for safety foods or TCS foods, except in processes where the growth of a toxin formation by the bacteria, Clostridium botulinum, and Listeria monocytogenes are controlled. So a variance is written approval from the state of Minnesota that a food establishment can demonstrate and support through research and literature that a deviation from an approved preparation or processing procedure will not pose a foodborne illness risk. So it's very, very, very likely that if you want to use ROP in your food service operation, like the ones we reviewed at the start of the webinar, that you are not going to need a variance request or a variance approval. This is saying that if you are going to want to use ROP in a way that differs from what we're going to talk about next, you would have to work with your health inspector and submit a variance request. You still need a HACCP plan and everything that entails. So just making you aware of this, but you will likely not need a variance request. You'll likely just need to have a HACCP plan created and reviewed with your health inspector. Okay. So now we'll focus on reduced oxygen packaging without a variance. So again, this means that you're going to need a HACCP plan and you're going to need to talk through it with your health inspector. But there's outside of that, there's not going to be any separate approval that you'll need to get. You'll see throughout some of these that it's going to reference another rule, 4626.1735, and that is just contents of a HACCP plan. So I've tried to include just little notations when you see some of these other rules referenced, so you know what that is. Okay, so if we're going to use reduced oxygen packaging in our food service operation, the first thing we need to do is identify what foods are going to be packaged. Because not all foods can be reduced oxygen packaged without a variance, which is what we're talking about. So in your HACCP plan, you'll need to list out individual food or recipe names, because again, not all foods can be reduced oxygen packaged without a variance. Additionally, after you have an approved plan, if you decide to add a new food or recipe, just contact your health inspector before making changes to determine if a new plan needs to be submitted. So I know with the Hutchinson School District, their inspector told them just to keep their list up to date, as long as those foods are meeting the requirements in the rest of the rule. So what foods can be reduced oxygen packaged? A quick note is this part 2, does not pertain to the cook chill or the sous vide. Right now, we're really just focusing on foods that are going to be vacuum sealed and stored. There will be a separate section that's going to talk about cook chill and sous vide. So like I've said, temperature control is a critical control point for reduced oxygen packaging. Keeping foods out of that temperature danger zone has a significant impact on limiting bacteria growth. So any food that's ROP must be kept cold at 41 degrees Fahrenheit or below and meet at least one of the following criteria. And these are the criteria that have an impact on bacteria growth. So if it's a prepared food, it should have a water activity of that 0.91 or less, or an acidity or a pH of 4.6 or less. So remember back to our discussion about water activity and pH impacting bacteria growth. So in your HACCP plan, planning process, you may want to consider adding steps of pre-chilling ingredients before packaging to help maintain that temperature while being handled. And if you're using if you're gonna do a prepared food, measure the pH or the water activity, or use tested recipes that show the food meets these parameters. Continuing on with the food requirements, again, the food must be at that 41 degrees Fahrenheit or below. It could be a meat or a poultry product that is cured at a USDA regulated processing plant, as identified in the Code of Federal Regulations. Or lastly, it could be a food with a high level of competing microorganisms. So that's our raw meat, raw poultry, our raw vegetables. Again, if there's that potential for a high level of competing bacteria, if a food was contaminated, any bacteria are going to have to compete for those resources, and then limiting the potential growth of just a single bacteria. So for your HACCP plan, making note that if you're going to be packaging raw raw items that they cannot be heated or cooked. They can be cleaned and trimmed before packaging, but meats, poultries, and vegetables, they all need to be raw. They can't be cooked. The vegetables can't be blanched. And again, it's because we want that high level of competing microorganisms when we're creating that anaerobic environment, and the cooking or the blanching would kill those competing microorganisms. So a few examples that meet the requirements of reduced oxygen packaging. So if we're looking at using water activity as one of those criteria, if you're making a jam or a jelly from fruit you purchase through local farms, or some baked goods, if you're sourcing some baked goods, you need to use tested or standardized recipes to make sure that water activity is correct. Again, pH, if you're making a fresh salsa or relish and then packaging it, you'll want to make sure that acidity is 4.6 or below. Raw meats, like raw meatballs, and then raw vegetables. Again, they can't be blanched. So you might want to just do some testing with the quality or the texture of the vegetables once thawed. So Amy shared the example of the basil that, if you normally freeze basil in just like a Ziploc baggie, it gets all nasty and slimy. But with the reduced oxygen packaging, it still stays really good quality once it is thawed. So just playing around with that, because some vegetables may not thaw as well. Again, they cannot be blanched. The next part of the rule details how the ROP food must be labeled and instructions for storage. So the ROP foods have additional labeling requirements compared to other foods that you're preparing in your food service operation. So the actual physical label must be easy to read. It must include instructions to keep the product cold at 41 degrees Fahrenheit or below. If you're going to store these ROP foods in the freezer, the instructions may also include store product in freezer until ready to use, thaw under refrigeration only. The label will also need to include space for dating. Depending on how you are storing the ROP foods, you may need to include lines to document the date packaged, the start date of refrigeration, the original date frozen, and the thaw date and the use by date. I have an example of a label on the next slide. So for your HACCP plan, include a sample label that you plan to use so your health inspector can review that and make any suggestions. And then ensure your storage procedure for these foods does not exceed 30 days in refrigerated temperature. So this is just an example of what your label might look like if you plan on freezing a reduced oxygen packaged food. So the label has space to document multiple dates, includes a reminder of that the food must be used within 30 days if refrigerated. And while it's not required in the rule except for reduced oxygen packaged fish, you could include instructions on this label to open the package once removed from the freezer for thawing, because this would change the environment from an anaerobic to an aerobic environment. Again, it is that specific action is required for raw fish. So ROP foods can only be at refrigerated temperatures for 30 days or less. If you freeze foods, the time in the freezer does not count towards the 30 days. So if we think back to time as one of the factors to control for bacteria growth, this 30 days is what's been established as a time frame that if something were to be growing, the risk is likely low. So it's important to train employees on how these foods are different from other foods being prepared in your operation that might have a 3 or a 7-day shelf life in the refrigerator. So include in your plan how you'll monitor these dates and storage of these foods. Part 5 of the rule provides detail of the operational procedures that you'll need to include in your HACCP plan. First, bare hand contact with ready-to-eat food is not allowed when packaging foods using reduced oxygen packaging. Because your school food service operations, you likely already have an SOP that addresses this and does not allow for bare hand contact with ready-to-eat foods since you are serving children. But it is included in the rule because other types of food services and food processing operations follow the same rule. In case you're wondering and you want to refresh yourself, the bare hand contact rule is on the screen. So in your HACCP plan, reference and include your existing SSOPs from your food safety plan about no bare hand contact. The next operational requirement focuses on the physical space and environment or equipment that will be used in the ROP process. So again, you likely already have SSOPs that address preventing cross-contamination, such as how equipment's going to be stored, how raw and ready-to-eat foods are not handled together. So in your HACCP plan, describe the area where the ROP is going to be occurring and reference your existing SSOPs. You may need to adjust them slightly to specifically mention reduced oxygen packaging, depending on how your SSOP is written. Again, have a conversation with your health inspector if you're unsure of how much detail they want or need to see in this part of the plan. Your plan must also detail who and what positions in your operation will be performing the reduced oxygen packaging and who will be monitoring and verifying. For example, the chef might be the individual trained for use on the equipment, and you as the manager are also trained, but maybe you're going to be the one responsible for monitoring and verifying. Or maybe it's a prep cook that's trained for use on the equipment and the chef is going to be the one monitoring and verifying. Your HACCP plan just really needs to detail or clarify which individuals are going to perform the procedure and who's going to monitor and verify. And the last operational procedure are your specifics about cleaning and sanitizing of the equipment and the food production space. So again, you already have SSOPs for cleaning and sanitizing, and you just might need to adjust them to mention the ROP equipment specifically. And you might need to have maybe a separate cleaning schedule or cleaning checklist because the ROP equipment probably isn't going to be used every day. So a different cleaning and sanitizing schedule and log might be needed rather than your daily or your weekly logs. And then just as with any procedure in your operation, you have training plans. So those responsible individuals are knowledgeable and can demonstrate the correct procedures and ability. So the training must include how to use the equipment and the packaging materials, what hazards are being controlled for and why, and the procedures that we just discussed in the past few slides. You must retain your documentation of this training and have annual trainings to keep the skills fresh. So in your HACCP plan, include a copy of the training, both initial and your annual refresher. And lastly, your plan must be submitted to and approved by your health inspector before you begin to use any reduced oxygen packaging methods. So I've said it earlier, but you know that first step is really having those conversations with your health inspector about your idea, about your plan, talk through it, and before you start to write a lot on paper, because they can help provide some additional resources and help troubleshoot. And then I mentioned this briefly, just a quick note about fish. If you do source fish from a local producer, the fillets need to be frozen before you package and then kept frozen until you're ready to prepare. And when you're ready to prepare, the fish can either be cooked right from frozen, or if you're going to thaw it, the fish need to be removed from the reduced oxygen packaging. The fish cannot be thawed in that sealed ROP package. There's just some different risks with fish, and this is the way to minimize that risk. So if fish is a food item that you do plan to reduce oxygen package, include the specific freezing and thawing steps in your HACCP plan. Okay. Take another really quick pause if there's any questions about this before we go into the cook, chill, and sous vide.
And just a reminder, if you do have a question, you can write it in the Q&A and we can answer it. But so far, we don't have any questions that have been submitted.
Excellent. Okay, so now there's just a few additional requirements that must be included in your HACCP plan if you're going to use cook, chill, or sous vide methods. You'll likely need 2 separate HACCP plans if you're going to use reduced oxygen packaging, just the vacuum packaging. And then if you're going to also do cook, chill, or sous vide. So this is the case with the Hutchinson School District. They had to create 2 separate plans. So I did make a note on all of these next following slides. So if you look at them later, you'll see that these ones are specific for cook, chill, and sous vide. So for these foods, they must be prepared and consumed within the same business entity. So if a school district has multiple kitchens, you may be able to transport the product to satellite kitchens for final cooking and service. And just make sure to have this discussion with your local health inspector before planning. So if after that conversation with your health inspector included in your HACCP plan that you're going to be delivering these ROP foods to satellite kitchens within your district, and that final cooking would occur in those satellite kitchens. For foods that use the cook chill method, they must be cooked to the appropriate minimum internal temperature before packaged. And for foods that will be sous vide, they must be cooked to the appropriate minimum internal temperature during the cooking. So in your HACCP plan, reference and include your existing policy about cooking temperatures. You must provide information on how you will protect the food from contamination before and after cooking. Again, you already have these procedures in place in your existing SSOPs. These can include bare hand contact, preventing contamination with taste testing, food storage, cooking, holding, cooling. Just reference these and include them in your HACCP plan. To package these foods, you can use the procedures from your vacuum sealing HACCP plan. And a new step to include in your procedure is the cooked chill foods that need to be at the temperature of 135 degrees or above when packaged, for the reasons we discussed. And in your HACCP plan, again, just reference back to those vacuum packaging steps and include the specific packaging temperature that you're going to use for your cooked chill foods. Your HACCP plan needs to show that these foods are going to be safely cooled following the cooling requirements of to 70 degrees within 2 hours, and then to 41 degrees or below within an additional 4 hours. So use your existing SSOPs. For foods that are cooked chill or sous vide, and you're going to keep them in the refrigerator, there's 2 different scenarios. First, if you want to keep these foods refrigerated for 30 days, the food must be cooled to 34 degrees Fahrenheit or below within 48 hours of being cooled to that 41 degrees. So again, it's 34 degrees if they're going to be held in refrigeration for 30 days. So think back to that listeria temperature growth. However, if you're going to hold foods at 41 degrees Fahrenheit or less, they can be in the refrigerator then for no more than 7 days. And again, if you're freezing these foods, the time frozen does not count towards these 30 days or the 7 days. So in your HACCP plan, just identify which criteria you're going to use. Because these foods require such strict temperature control, you may need to make a change to your temperature monitoring system. So have that discussion with your health inspector to determine if your current temperature monitoring system meets this requirement. It's like some units have a log where the temperature is constantly measured and recorded digitally, and others don't. And so you may need to purchase a device. So I know the Hutchinson School District, they had to purchase a device. And again, because these foods require the strict temperature control, if you're transporting to a satellite kitchen within your district, again, you may need to make a change to your temperature monitoring device. Review that with your health inspector, and they'll help you determine if you need to make a change to your system. And then lastly, ensure all the foods are properly labeled and dated. So in your HACCP plan, reference your date marking and your labeling SSOPs and include a sample label. And then again, because temperature control is so important in these foods, your HACCP plan must include detailed temperature records for cooling and cold holding, include copies of your logs and your templates in your HACCP plan, and your procedure for storing these logs. And then finally, the HACCP plan must include procedures that prevent cross-contamination and your training program. So you already have all of these procedures for other things in your kitchen, so apply them to this plan. So a couple examples, visuals of what would meet these requirements. Here we have some homemade tomato sauces, potatoes, and soups that were cooked chilled and then now are being stored in the freezer. And remember, it's these dense foods that produce a lot of steam that are good for cook chill. And then here we have chicken that's going to be sous vide. It's got a nice marinade in there and going to be cooked in that with that process. And then just quick notes, if you are going to use vacuum packaging, there are some special requirements for cheese. And if you are just using vacuum packaging to do like that quick marinade, and the food is only going to be in that package for less than 48 hours and these labeling requirements are met, a HACCP plan is not required. Okay. So now I just want to jump into HACCP plans unless there's any questions. No questions.
No
Okay.
questions.
Okay. So earlier we talked about those differences between a food safety plan and a HACCP plan. So just a reminder that the food safety plan contains all of the SOPs and other procedures that promote food safety in your operation. And the HACCP plan is specifically addressing the unique potential hazards associated with the reduced oxygen packaging. So as we went through the food code, I included some points to include in your HACCP plan in those orange notepads. And before we wrap up, I just want to kind of talk about or give an example of some of these steps. So there are the 12 steps to a HACCP plan. The first 5 steps are really just setting yourself up for success. You're determining what foods you're going to look at and the path that food is going to follow in your operation. The remaining steps are where you're getting into kind of that nitty-gritty, identifying those food safety concerns and what you're going to do in your operation to minimize those risks. So a sample flow diagram is what you're seeing here, and this is for vacuum packaging. So a flow diagram is really you're just drawing out the path that the food is going to take in your operation, and then you're looking at each one of these steps for any type of risks. And if there's going to be risks, you might label those as a CCP, which is a critical control point. And we'll talk about those here next. So when you're conducting your hazard analysis, you're looking at your operational step, you're naming any of the potential hazards, and then the preventative measures. And is it a critical control point? A lot of these will not be a critical control point because you already have existing procedures in place that are going to help minimize that risk. But when we look at the preparation step with reduced oxygen packaging, we're creating that potential hazard of that anaerobic environment. And we know that now there's a risk with Clostridium and Listeria. So this is not addressed in our normal procedures. So it is a critical control point, and we're going to have to put some preventative measures in place, which are our time and our temperature controls. So when you're identifying your critical control points, you're asking yourself, what are the actions that can be taken to minimize the risk of the hazard? So in our example of the vacuum packaging of a raw food and creating that anaerobic environment, We want to hold at a cold temperature, and we want to limit the amount of time that the food is stored. That's what we're going to control. Once we know our critical control points, we need to establish the limits. So what is the parameter that we're going to control to? So another way of looking at it is, what is the maximum temp, or what's the maximum amount of time? So again, going back to our example, our critical limit is going to be 41 degrees Fahrenheit or below, and no more than 30 days at refrigeration. Then you're getting into your monitoring. So you're asking yourself these kind of questions, you know, what's going to be monitored? How will it be monitored? What frequency? Who? So this will be very individualized to your operation. But these are some of the potential considerations. Then your corrective actions. So you're all familiar with corrective actions for other procedures in a kitchen, like if a sanitizer doesn't meet concentration. So you're thinking, okay, what am I going to do if that critical limit is exceeded? So if it goes above 41 degrees Fahrenheit, or if it's been in the refrigerator for 31 days because it got pushed behind something. Unfortunately, with these type of foods, the corrective action is probably going to have to be discard that product. Then you have your verification. So again, asking who is going to check and who's going to monitor, and how often will this be done? And then your record keeping. What documentation are you going to keep, and for how long? So Leslie, the food service director at Hutchinson School District, could not be here with us today, but she did share some words of wisdom as they went through this process and are still kind of going through it. That, you know, ask for help, ask lots of questions, be persistent with your health inspector, stay on top of them, get the follow-up that you need. Be creative, think outside the box about what kind of foods and recipes you want to use, and plan for the long-term investment in your schools. You know, this might be quite a bit of work right up front, but once you get a good plan in place, you'll really be able to start to see those potential benefits of reduced oxygen packaging. That is all of the information we have today. The recording and some resources will be up on the Farm to School website here in the near future. Like Kate said, we will share that. If there are any questions that came through now.
No questions yet, but there's time if anyone wants to still put in a question in the Q&A, we can answer it.
Okay. And we'll share this link as well, or if you want to scan the QR code. If you're attending this today, and you would like a continuing education certificate that can be applied to your certified food protection manager, please complete the survey, and then we'll get a continuing ed certificate sent out to you by the end of the month.
Great, and just a reminder that this is the first of our kind of 3-part webinar series. So if you're interested in joining for one of our next 2 webinars, we'll have another webinar on April 17th, really focused on local animal proteins and understanding food safety considerations and requirements around that, as well as information on how to make sure that the animal proteins that you're buying and serving are accrediting for federal meal programs. And then on May 1st, we'll be talking about kind of wild foods and more. So think honey, maple syrup, wild rice. Microgreens aren't necessarily wild, but we get a lot of questions on them. So really trying to hit some of those foods that maybe you've been thinking of purchasing but haven't tried yet. We'll hopefully answer some questions that you may have on those items. So we hope you'll join us next month. And with that, I think the final slide is just Amy's contact information. So I want to say thank you so much, Amy, as well as Amy and Rob from Hutchinson, Litchfield, Dassel, Cato. Thank you all for sharing your expertise and experience with this. This was such a wealth of information and hopefully helpful for those of you who joined today or are watching this at a later date. But yeah, thanks so much. And if you do have questions, you can reach out to Amy Johnston, and Amy's contact information is here on the page. Thank you.